I'd ask that you turn your attention with me over to the sideboard here, okay? Geometry, our third row, second from the bottom. SWBA, what's that stand for, guys? Students will be able to, the T is silent, okay? Measure linear segment section 1.2, okay? So that's what we're going to be doing today, right? So, let me talk about this idea of a postulate. A postulate. A postulate is also known as an axiom, okay? It's also known as an axiom, okay? That's a weird word, I know, okay? And I know this page printed really weirdly, guys. I'm sorry about that. I didn't realize it until after I had already gotten all of the copies that it printed weirdly, and so I didn't want to go back and have to change, go back and print a bunch of new ones. So we're just going to struggle through it for just this page, and the rest of it's fine. Okay.
It's not okay.
So a postulate or an axiom. Okay. Now we'll call it a postulate more often than not. It's a rule that is accepted without proof. Now you guys need to write the word proof in as well because it got cut off. I had to write it in on my copy. Okay. It's a rule that's accepted without proof. Whereas a theorem is a rule that can be proven. It's a rule that can be proven, okay? So a postulate is kind of like our undefined terms we had last week, where we had like a point, a line, and a plane, okay? We just said we accept them as is. Then we had defined terms that were built on top of that. You guys do not have to do what I'm about to do up here, okay? But I want everyone's eyes up here. I want everyone's eyes up here, but you guys don't have to write this down, okay? Don't write this down. So we have these postulates down here, along with our undefined terms, okay? Now these are our first layer, our building blocks of geometry, okay? These are the things we accept just to be true. We say, hey, these things we're going to accept as truth. Then from that, we built up theorems. Because we have things that we accept to be true, we can have theorems, and we can have our defined terms, okay? And then from that, we can keep building up more and more and more. Because we have these postulates and undefined terms, I believe there's 23 postulates, if I remember correctly. Maybe it was 21. But anyway, postulates and undefined terms. And then we have different theorems and defined terms that are built on top of that. So from that, we get this whole framework that we call geometry. Okay. Now, there are actually different types of geometry around the world, and just different random ones that have popped up over the years. But this is by far the most common geometry, so it's the one we use and utilize in class here, and it's the only one we'll cover. But what it would be is there's a different postulate or a different theorem, and we end up changing it, and so it changes what happens after it, kind of like a butterfly effect kind of thing, a chain effect, chain reaction. But here, you have these different building blocks, so we get this framework. Okay, moving on from that. We are in our math note packet, section 1.2. Okay, absolute value. You guys have seen this before in algebra. Okay, absolute value. We're gonna word it a little bit differently than you might have seen it before. Okay, it's the distance a given point is from 0, and you can just do the number if you'd like, from 0 on a number line, and it is always positive. Okay, you guys don't have a blank there; it got cut off. You can write it underneath something. It is always positive. Can anyone not see this color that I'm writing, by the way? Okay, just wanted to make sure. So we already have a postulate, okay? And it deals with measuring segment length. This is just something we accept as true. Measuring segment length. Also call that distance. Call that segment length distance, the length of a segment. Okay? So what we're saying is absolute value of x2 minus x1. Now, you guys remember like the slope formula from before? M is equal to y2 minus y1 over x2 minus x1. You don't have to write that slope down. Okay, don't write this down. Was this saying 2 times y? No, it was saying the second y coordinate. It's like this is saying the first y coordinate, okay? This is saying the second x and the first x. That's all this is saying. It's saying the second x and the first x. So What we're saying here is if we take the difference of the two numbers, subtract, and we take the absolute value, that's the distance. So it's like we're saying, how far is 5 away from 3? You do the absolute value of 5 minus 3. Okay? Well, what is 5 minus 3? 2, right? What's the absolute value of 2? How far is 2 away from 0? 2, okay? It makes it positive always, but it's already positive, okay? So we know 5 is 2 numbers away from 3. Okay, 2 units away. Now, this says x2 minus x1. What if I switched them? Let's think about what would happen if I switched them here. Now, normally, can we switch subtraction? Is it still the same? No, it's normally not. So let's look at what happens here with these absolute value brackets. If I do 3 minus 5, we have the absolute value, but still. What's 3 minus 5? Negative 2. What's the absolute value of negative 2, though? Positive 2. So does it still end up being the same? Yeah. Okay, let's think about it this way. If I drive to Bellevue from Plattsmouth, is it the same distance as if I drive from Bellevue to Plattsmouth? If I drive Plattsmouth to Bellevue, is it the same distance as Bellevue to Plattsmouth? Yeah. So it doesn't matter which way you're going on the trip, whether you're going there or back, it's still the same distance regardless, and that's what we're saying here. That's why we have it as the absolute value, so that way we have it positive. And that way we don't end up with a distance like negative 2, because you can't have it. It's not like I drive negative 15 minutes up to Bellevue, and I drive positive 15 minutes to Plattsmouth from Bellevue. That'd be weird, right? Okay. Right here, A and B, that is the name of the points, okay? We're naming the points. That's the name of our points. We know that. We've used that this last section here to name our points. Whereas x sub 1 and x sub 2, x1 and x2, those are the coordinates of the points. Okay, just like we had x comma y, coordinates of the points. Questions on that? Does anybody still need this before I move? Gucci gang. Okay, let's look down to that number line here, okay? So we're finding the distance between 2 points. Finding the distance between 2 points. In this case, finding the distance between T and W. So according to our measuring distance that we had, right above here, we need to use the absolute value of x2 minus x1. So what value is T at? Negative 4. So let's plug that in. Negative 4 minus what? Where's W? 10. So notice I just took this same. I took the x2 minus x1, the absolute value of x2 minus x1, and I just substituted in T and W for x2 and x1. And we said, hey, does it matter which one's which? No, we said it didn't matter. Okay, we said if we got 2 either way last time. It's like if you go to Bellevue from here, or you go the other way, it's the same distance. Okay? What is negative 4 minus 10? Negative 4 becoming 10 less. Negative 14. Okay, they have the same symbol, negative and a negative, so you add them together, get 14, and you keep the sign. Okay? Think about it this way. You owe someone $4. You have negative $4 because you owe them $4. You borrow 10 more. How much do you owe them now? 14. You added them together. Okay? What's the absolute value of negative 14? Positive 14. Okay, and that's our answer. Positive because it's absolute value. It's distance. Yeah. Yep. We got to be careful. Hey, how could we have checked using this number line? Could we count? Yeah, okay, I heard someone call it last class baby butt cheeks. Okay, we can count. We're at 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Hey, we got it right. Okay? When I count, do I count 1, 2? Or do I just go 1, right? Okay. Now I want you guys to write in, we have letter A is TW. I want you guys to write in problem B, the distance between VW. The distance between V and W. And I want you guys to find that on your own right now. I want you guys to find the distance between V and W on your own right now. So go ahead and do that, please.
You want us to do the whole thing or you do it?
You can do it however you want. When you're finished, I want you to stand up. When you're finished, I want you to stand up.
V and W. When I sit down on the bathroom, are you standing there?
Find a little bit of space, find a little bit of space, enough space to do a jumping jack, okay? Enough space to do a jumping jack, okay? Let's do 3 jumping jacks and everyone count. 3 jumping jacks, everyone count, okay? Let's go. 1, 2, 3. Okay, let's sit back down. Okay. Get the blood going a bit. Get the blood going a bit. Okay? What was our distance between V and W? 2, right? It was 2. Could you just count if you want?
Yeah.
Yes. Could you also go through and say the absolute value of 8 minus 10 and say, oh, 8 minus 10 is negative 2. Absolute value of negative 2 is 2. Okay? You can do that as well. Or you can do 10 minus 8 and get 2. Okay? Lots of different ways. Any questions on that? So, okay, let's look right below this. Okay? Congruent segments. What's a congruent segment? We haven't learned that word. We're learning it now. Okay? These are segments that are equal in length. When 2 segments have the same length, we say they are congruent. Okay? When 2 segments have the same length, when their measures are equal, we say they're congruent. Okay? We have a symbol for it. Your guys just says symbo. Okay? Bless you and bless the rain down in after bless we forget. Your guys just says symbo. It's symbol. Okay? And the symbol for this, it's like an equal sign, but we add a tilde to it. It's like an equal sign, but we add a tilde to it. Okay, that's our symbol, or for you it's a symbo. Okay, symbo. Okay, but it's like an equal sign with a tilde. Okay. Hey, so I know in Spanish the tilde tells you to pronounce something different, right? Like jalapeno is really jalapeno. Okay. Now here, even though there's a tilde on it, you don't just say, oh, instead of equal, it's like equal or something like that. No, it's congruent. Okay, we call it a whole different word in math. It's congruent. Okay, that'd be quite weird. It's not even what the tilde sounds weird, but it doesn't make it sound different. It's a different word, and we use it as a symbol in math. Okay, it almost kind of looks like a toothbrush with toothpaste on it. But anyway, that's what congruent. That's a congruent symbol, and it means 2 segments are the same length. Example 2 says, name 2 congruent segments from the number line above. Name 2 congruent segments from the number line above. Let's look at that number line. Does anyone see any 2 segments here that could be the same length? Okay, ST. How long is ST? 1, 2, 3. Okay. Compared to what? TU. 1, 2, 3. Hey, those look like they're the same length. That's awesome. Okay. So what that means, since they're the same length, is that going back down here, that segment ST is congruent to segment TU. Okay, so I want you guys to write that in there. That segment ST is congruent to segment TU. And that's because they are the same length. Math declared it true. You get math declared it true. Okay? Example 3. Name all congruent segments that you see in the figure below. Hint labeling. Okay, I know that hint labeling up to the far left is really for this stuff. Okay. The labels. These tick marks here, that's a way we show that 2 segments are congruent to each other. Now here's the thing. Does it look like this one with the 1 tick mark is congruent to the one with 2 tick marks? No. What does it look like it's congruent to? The other one with 1 tick mark. Okay. The tick marks are important. 1 and 1, they're congruent to each other. 2 and 2, congruent to each other. 3 and 3, congruent to each other. If they're different numbers, 3 and 2, not congruent. 3 and 1, not congruent. Okay? So who can, so if I say segment FG is congruent to which segment here?
FG
Is CD. Could we also call it DC if we wanted? Sure.
How do you tell which letters for which one?
It's the points.
So we're not comparing lines, we're comparing
We're comparing the segments, okay? But we look at the one tick mark right here, and it's a segment that connects G and F. So we call it segment GF. Those are the endpoints of the segment. Does that answer your question? Okay, good question. Okay, somebody want to give me another pair of congruent segments here. Another pair of congruent segments here. Colton.
AG and BC.
Awesome. Segment AG is in fact congruent to segment BC. Very good. And we have one more pair here left. Okay, Peyton, can I count on you? Okay, we covered the one tick marks, we covered the two tick marks. How many tick marks do we still have left to do? The 3, okay? So what are the endpoints of this segment? Okay, so segment FE is congruent to segment what, Peyton? ED, very good. Bless you and bless the rains out and after, lest we forget, okay? Very good. ED, could we also have called it DE? Sure, do we have to? No. Okay? Are there any that we're missing in here now? No. Okay? Is AB congruent to anything? Not marked. Okay? For a clarification as well, if I said AB and segment GF, are those congruent? No. So just like you can put not equal and put a slash, we can do the same thing. We can put congruent, put a slash, and it says not congruent. Okay? I want you guys to write that in there. You can put not congruent too. So the congruent symbol with a slash, and it's not congruent. Now we have a difference between our distance and our segment. Okay? Distance is the number, and numbers can be equal. Segments are parts, and they are not equal. They are congruent. Okay? It's a little bit of a technical difference there. So distance, I can say the measure of segment FG is equal to the measure of segment CD. And those would both be equal to some number. Okay? So I can say the measure of segment FG is equal to the measure of segment CD, and they're both equal to some number. However, if I'm talking about the segments, I would say the segment of FG, segment FG is congruent to the segment CD.
You don't have to put an S for
No, so the reason I had M is there's a little m whenever you talk about the measure. We'll use that a lot in geometry, actually. But the symbol above tells us there are segments. So you read this little thing as the measure of segment FG. And little m in front of it will mean measure. Measure of segment FG. So we're saying those are both equal to some number, and they're equal to the same number, so they're equal. However, the segments, though, are congruent. Questions on that before we go to the next page? Let's flip it over to the next page here. Oh, I'll give you a second. I almost know that I missed your concept.
Good.
Gucci gang. Okay. We're told to plot these points. Plot J, K, L, and M in a coordinate plane. That's our first step. We have our origin. From the origin, where do I go to plot J? -3. Down here?
No.
No, where do I go 3?
left.
To the left. The X is first, so I go left or right first. Okay? Then where do I go 4? Up. 4. So I'm at -3, comma 4. You read left. You do the X first, then Y. X, comma Y, just like the alphabet. So you do the left and right, then you do the up and the down. Okay? Where would K be from the origin? How many to the right?
2.
Then where would I go 4 to? Up. Okay? What about L? Where would I go with that from the origin? 1 to the right, up 3. Okay? What about M? Right 1, down 2. Very good. You remember X and Y. Then determine whether segment JK and segment LM are congruent. What would it mean for them to be congruent? They have the same distance, length, measure, any of those words. Okay, that means we need these segments in here. Let me put those segments in there. Isn't that fancy? Isn't that pretty neat? It's pretty cool. I would love you to draw lines. Okay. Now, how are we gonna be able to figure out the measure of these points? We can just count, right? Okay. 1, 2, 3, 4, 5. So the measure, I want you to write this off to the side. The measure of segment JK is equal to what number? 5. Okay. What would the measure of segment LM be equal to? It is 5. So write that off to the side too. The measure of segment LM is equal to 5. Are the measures the same? What does that tell us about the segments themselves? They're congruent. So let's write that in there. JK is congruent to segment LM. In algebra, when you showed your work, that was solving the equation, right? In geometry, sometimes that's showing your work too. But in geometry, this is also our work. This is how you can show work sometimes in geometry, okay? Kind of looks different sometimes. Questions on that? Okay. This next part here, it's called segment addition. This is another postulate of ours, okay? What we're saying is, A to B the whole segment right now? No, it's part of it. It's its own segment, but it's part of the whole thing. Okay? Is B to C the whole segment? No, but it's part of it. Okay, what is the whole segment then? AC. AC is the whole segment. Now, could I add up this part and this part, or would I get the whole? Yeah. If I add up this part and this part, I get the whole thing. Okay? That's like saying, if I add the distance from me to Kale, and from Kale to the back of the room, would you get the whole distance from me to the back of the room? Yeah, if I add the distance from me to Kale, and from Kale to the back of the room, we get the whole thing. So 2 parts make the whole. That's what we're saying here, okay? So we're saying part plus part equals the whole thing. We're just saying we can add 2 segments together and you get the whole thing. So on example 5 here, if we're saying AB has a length of 13 and BC has a length of 27, what math could we do? What math could we do to get AC? Addition. When we just add these 2 together, right? We add the 2 parts. And what do we get when you add 13 and 27? 40. You get 40. 13 and 27 would make 40. Okay, we can add off the side 27 plus 13. Okay, 3 plus 7 is 10. Carry the 1. 1, 2, and 1 make 4. Okay, 1 plus 2 is 3. Plus 1 is 4. So we can say the measure, so I went to write it, the measure of segment AC is equal to 40. Okay, whenever you're answering the measure or the length of something, I want you to write the measure of segment AC, the measure of the segment is equal to 40. If you don't know the unit, we're just going to leave it blank for units, okay? If we were told feet, we write feet. If we were told inches, we write inches. That's what we were asked to find the length of AC. And if you add up the 2 parts, you get the whole thing, which is AC. Okay? Questions on that? Okay, let's go right below this, okay? So we knew that 13 plus 27 would equal the whole thing. Actually, before I go below this, let's talk here for another second. So this whole thing, did we know AC when we started this problem? No, what could we have called it if we didn't know it? X, cool. Okay, so we did 13 plus 27 is equal to X. Is that really our same thing as part plus part equals whole? Yeah, okay. Let's use that on this next problem. Okay? Find the length of GH. Do we know what the length of GH is right now? No. What can we call it? Cool, we'll call it X. Okay? So we know that part plus what equals whole? Part plus part equals whole. So could I say 21 plus what? X equals 36. Yeah, we just substituted in what we didn't know. You just substitute those parts into the part plus whole. And we get an equation now to where we can now find GH. Questions on how we got that equation? How How would we solve this equation? This takes us back to our algebra days. Gracie,
Subtraction.
subtract what?
36, like 21 from 36.
Subtract 21 from both sides, okay? Because what's 21 minus 21?
0.
0. 21, okay? Now we're just left with x is equal to, what's 36 minus 21? 15. So what's the length of GH? 15. So the measure of GH, segment GH is 15.
Why is that side smaller?
Great question. So tests like the ACT and standardized tests do this stuff all the time, where this is 21 and this is 15. 21 looks way smaller than 15. That's weird. That's wrong. ACT does that stuff all the time, where the picture's not drawn to scale. They'll say that all the time. So you can't always go off of this picture and be like, well, that can't be 15. Sometimes they just like to screw with you. That's what's up it. All right. Questions on that? Okay, I don't know, right? Getting disrespect is real. Okay. Hey, let's talk about this one. We're going to talk about setting this one up here. Find the value of x and the segment JK. This is between J and K. If K is between J and L. Okay, what have we been working with? What kind of parts? We've been working with rays. We've been working with points. We've been working with line segments. So what are we probably going to draw here? A line segment, okay? So we know a line segment has two endpoints at least. Okay, it has two endpoints and it can have points in between. Do we know what our endpoints are? J and L. How do we know they're J and L? It's on the board. Okay, it says K is between J and L. You know J and L are at the end. Does it matter where we put K between these two? Will it actually affect it though? No, we can just put it there. It's okay if it's not completely accurate like the picture above. Now that we have this picture, could I go in and could I now label these different things? I can now say, hey, if we're told these different measures, could I write that in and label our picture? I think that'd be a great move. So let's label JK. I like to label it like this, as you guys have kind of seen. I think that's a good way to do it to where it's pretty clear what you mean. Like what part's what. So we're told JK is 3x minus 4. We're told KL is what? 5x plus 8. Okay? And we're told the whole thing, JL, is 140. The whole thing is 140, okay? Could we do part plus part equals whole here? Okay, what would be our two parts? 3x minus 4 and awesome, 5x plus 8, thank you very much, equals the whole thing, which is 140, okay? That's how we set up our equation, okay? And Nolan hit it right on the head of how we solve it. How would you start solving it? You said combine like terms, right? Okay. I'm actually going to have us hold off on solving that now because that bell's about to ring. We're about to go to lunch. And I'm going to be mean, Mr. Costa. I'm going to pass out a worksheet real quick, guys. I'm sorry. Like I said, once we get rolling here more in the next few days, we'll get out of this rhythm. We'll only have it every now and then, but today, it is at the end of class. I'm sorry for that, okay? I'm trying to not make that a consistent thing for you. I know it's not a lot of fun. We'll get some more time here in the coming days. Okay? This is front and back. I do want you to do it all, but the back's pretty short as far as number of problems. It's a lot shorter assignment than this one. A lot less questions. Okay? Otherwise, have a great day. This is what we do on Tuesday. I got 3 minutes. We do on Tuesday. If I went too fast, you can watch the video on Classroom, right? You don't have to watch the whole thing. You can watch the part that I went too fast for. If you lose your copy, you can go on Classroom. You can ask me for another one.